Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, we will see the concept of vectors in terms of distance from a point to a line. This concept is asked in various ways. So I'm preparing 3 videos and you will find the link of each video in the description. So this question I've taken from June 22, variant 3.1. So let's see the question. Okay, so in this question, first of all, note down the important length and sides so that you can mention it in the diagram. OA is equals to 2 unit. So this whole line is equals to 2 unit, right? So if I will write in terms of ijk, I will write 2i. Now if you see OC is equals to 4 unit, it means from here till here, it is 4j. If I use this side, it will be 4j. If I will use in the reverse order, it will be minus 4j. Right, this is the basic concept we will apply here. And then OG is equals to 2 unit. Okay, so now let me write here. So this is OG going from here till here. It is 2j, 2k, sorry. Right, so now we know that this is 2, this is 4, and this OG is also 2 unit, right? So now the rest of the thing is, this information is also important. AN is equals to 3NB. So ratio wise, AN has 3 ratios and this has 1 ratio. Okay, so the complete AB is equals to 4J, but AN will be 3J and NB will be J. So let's start solving a question. We have to express vector OM. Now it is given to you here that M is the midpoint of DF, and DF is basically the diagonal of the top rectangle. Okay, this is the rectangle you can see here. So this M is exactly in the center. Now imagine, you can see wherever you're sitting in the room, this is exactly in the center. So if you are going from O to M, you can't go like this. You have to go along the direction of I, J and K. That is the rule. So now, first of all, we will go from O to J. There are 2-3 ways. This is the way I'm taking. So to find out OM, first of all, I will go from O to G. Then from G to mid of GF, right? Mid. So I can say plus half of GF. Okay. Then plus in this direction I will come. This is a perpendicular line. Now this whole thing was 2 unit because it is from here. Now I'm coming in this direction, so it will be 1I. Okay, I'm calling it 1I. 1I. And it is in this direction, and I is also in this direction. Okay, so now instead of OG, I will write here what? I will write 2K. Instead of GF, because this was J direction and the whole thing was 4, so center will be 2J. So I will write 2J, right? Sorry, this half I will not write because half of GF is actually 2J, and then it is I. So I got here OM. So OM is I plus 2J plus 2K. So this is the vector you have found. Now let's find out MN. MN. So again you have to see how you will move. Let me erase all these lines so that it's easy to see the diagram. Okay, now I have to go from M to N. This is M to N. So what route you will take? Along, again you will take in the direction of IJK. So for example, because it is in the center, I go all the way from here till here. Right? Now, this whole thing was actually 4J, right? We saw from here. It's parallel to it. So because it is halfway, it will be 2J. So I will write here 2J. Later we will arrange it in the IJK form. Then I'm coming all the way down here. Okay, I have to come to n. So because this was 2k, it is in this direction, so it will be minus 2k. There is no calculation required, you just have to read properly, and that's all. Minus 2k. Then I'm coming here in this direction. So this will be 1i because this whole is 2i. We got this from here. So it will be 1i plus, later I will remove 1. Right now I'm just writing it. Then b to n. Okay. And bn is actually 1/4 of ba. I'm repeating bn because it is 1 ratio and this is 3 ratio. All together it is 4. So this portion is 1/4 of BA. And what is BA? BA and CO is same thing. Let me erase this so that you can understand what I'm saying. So I'm repeating, your BA is same as CO and CO will be minus 4J. So you will write here Bn, right? I'm writing for Bn. Bn is equals to 1/4 of BA. I'm writing in detail everything. You can write it directly if you want. So it is 2J minus 2K plus I plus 1/4 and BA is minus 4J. Right? You can see from here diagram. So 4 cancel with 4 and you are left with minus J. So 2J minus 2K plus I minus J. Sorry. And then I will just write it in the IJ form. So it is I plus J minus 2K. Right? Because 2J and minus J is equals to 1J. So I got here OM and MN vectors. So this part is done. Now question is saying find a vector equation. Find a vector equation for the line through M and N. We know when we are writing a vector equation, what is the equation general? A plus lambda B, where B is the direction vector and A is a fixed point on it. Now if you see at the moment, I know point M. Point M is actually OM, which we are getting here, which is this case. Okay, so this point I'm writing in place of A, and choice is yours. You want to write in the column vector form or in the IJK form. I'm writing in the column vector form. To me it is easy to handle. Now B is the direction vector because the line is MN. So I will take the direction vector of MN, which is given here. Right? MN is called displacement vector, or it is the direction of the vector line which is passing through M to N. So I can write here 1, 1, minus 2. So this is my vector equation of the line MN. Okay. After that, the question is saying, show that the length of the perpendicular from O to the line MN is this. Now, what is my MN? Let me erase this part so that I can explain it to you on a clean diagram. Give me 1 second. Okay. Now, so I have to draw or find out this distance, perpendicular distance from O to MN. So let me draw here roughly. Okay. Suppose this is my line MN and this was O. I have to find out this distance. Okay. According to the diagram. Now the line MN I already have here. Okay. This question was saying find the equation of the line MN. Now you must know that this line which is going from O to MN is perpendicular, because when question is saying find the shortest distance or perpendicular distance, it is understood it is perpendicular. In this question it is given to you. Let me call it F, point F. So to find out this distance, basically I have to find out vector OF. And once I will find vector OF, I will find out its modulus. That will give me the perpendicular distance from O to the line MN. Okay. So the whole target is how to find OF. Now one thing I would like to tell you here, this line equation which you have found here, the value of lambda, as it changes, the position of the point on the line changes. I'm repeating what I'm saying. The value of lambda which you will get will basically change the position of the point on the line MN. So F is also one point, and for this position of F, there is certain value of lambda. So I can use this equation for OF. So let me write here. So line OF will be, I'm getting from here 1 plus lambda, 2 plus lambda, 2 minus 2 lambda, right? This is I have written in the form XYZ form. Now one thing, this direction and the direction of the line MN, they are perpendicular to each other. And we know when two vectors are perpendicular to each other, their dot product is 0. So I can say OF, and this is the direction of the line, right? This is the direction of the line because of this vector, we know that. I'm writing here in case if you are not getting it, this vector is actually the direction 1, 1, minus 2. Okay, so I will write here 1, 1, minus 2. Okay, direction of OF, which is this, and direction of the line are perpendicular to each other. So now I will just simplify it to get the value of lambda. 1 plus lambda, 2 plus lambda, 2 minus 2 lambda. I will take the dot product with 1, 1, minus 2. Okay, and you know how to apply dot product. This into this, plus this into this, plus this into this. So I'm going to do this. 1 plus lambda times 1 plus 2 plus lambda minus 2 times 2 minus 2 lambda, right? And now I will simply open it, expand it, and solve it to get the value of lambda. So 4, 5, 6, it will be 6 lambda minus 1 equals to 0. So lambda equals to 1 over 6. I told you in the beginning to find the shortest or perpendicular distance from O to the line MN, I need OF. So OF is given here. So I will substitute the lambda in it, and then I will take magnitude of it. Okay, so OF is 1 plus 1 over 6. I'm just substituting the value of lambda here, right? It's 2 plus 1 over 6. 2 minus 2 times 1 over 6. So this will give me 7 over 6, 13 over 6, and this will be, for example, it will be what? 5 over 3, right? So I got my vector OF. Now to find the shortest distance, I need the modulus of it. Simple. Okay, so now I'm getting the modulus of this. So it will be 7 over 6 square plus 13 over 6 square plus 5 over 3 square. So you can use the calculator now. Let me also use the calculator. So I got the answer here, 318 over 36, which is actually equals to 53 upon 6. And it is proved. This is what you have to prove, that the shortest distance from the point O to the line MN is 53 upon 6 in root. So I hope you understood this question. You can share it with your friend and press like and subscribe button. And I'm making 2 more videos on the same concept from the past paper, so you can see that also. Thank you very much. Take care.